Okay, assalamualaikum and hello everyone. So today we're going to finish off 4.4, which is reactions of organic compounds. So what are the reactions that will occur within chemistry with organic compounds? So your learning objectives is that you will learn how to explain covalent bond cleavage. Cleavage means that you're gonna cleave. Okay, cleaving maksudnya cut your bond. So there's two ways. There's homolytic cleavage dengan heterolytic cleavage. And then you're gonna have to differentiate between those two, and then you want to know how to compare the relative stabilities of your primary, secondary and tertiary reaction intermediates. Okay, so these are your reaction intermediates. So what you will form before you form your product, the intermediate, whether or not it will form product or reactant. And then you're going to compare the stabilities in carbocation and carboanions using this thing, inductive effect of alkyl group. So that means that how does your alkyl group, the number of alkyl group, okay, will affect your reaction intermediate punya stability. Okay, and then you're going to define electrophile and nucleophile. So what are they? What are the examples of these two species? And then you will also define Lewis acid and Lewis base. Yang ni awak dah belajar masa chapter 6 I think. Chapter 7, acid base. Alright. So basically Lewis acid is just electron acceptor. Lewis base is electron donor. And then you have to know these types of reactions. So there are 4 types of reactions. So bila diminta types of reactions, it's only addition, substitution, elimination or rearrangement. Tapi ada dia punya specific term lah, electrophilic addition ke, nucleophilic addition ke. Okay, we'll see how you want to get that right later. Okay, so the questions in your tutorial basically akan keluar juga. Dia give a reaction equation and then you have to name the type of reaction. Okay. Alright, reactions of organic compounds. So reactions of organic compounds. So in organic chemistry, of course lah, chemistry pun you will have reactions. So these reactions will happen when you form and break your covalent bonds. Okay, so that is how reactions happen. So there's 2 ways for you to break your covalent bond. First, you have homolytic cleavage. Okay, and then second you have heterolytic cleavage. So tadi saya cakap cleave is to cut, right? Okay, you're going to cleave your bond. So let's see the first one, homolytic cleavage. What does it mean? So homolytic cleavage, how does it happen? It occurs in a non-polar bond. Okay, non-polar bond of 2 atoms of similar electronegativity. Contohnya macam Cl2, Br2. Okay, so you have molecules of the same atom, so same electronegativity. So right here you have the reaction equation. Alright, so for homolytic cleavage, in order for you to break this bond here, single bond, you will need to have presence of UV radiation or light. So you need this because to break this bond you need a lot of energy. Alright, so you're gonna break this bond. Okay, so what happens in homolytic cleavage is that a single bond breaks symmetrically. So dia akan break secara equally. Okay, break equally into 2 equal parts, leaving each atom with 1 unpaired electron known as a free radical as the product. Alright, so what happens is that this is the first half-headed arrow, okay, or single-headed arrow. So that shows that 1 electron will be accepted by one of the atoms, and then you will form a free radical. So this is called a free radical when you have an unpaired electron on that compound, that element, that molecule, that atom. Okay, the second arrow is that, okay, awak can tunjuk juga your half-headed arrow, your curly arrow. Okay, So that's homolytic cleavage. You cleave that bond, cut it, then you will get your free radicals. So you have unpaired electrons. Okay. Alright, so that's homolytic cleavage. So these are examples of the molecules that will undergo homolytic cleavage. Ini yang first one you already see. So the Cl undergo homolytic cleavage and you will get free radicals, chlorine atom free radicals. Okay, so kalau yang macam ni, this example, okay, how do we know where do we cleave your bond? Which single bond are we cleaving? So we look at the product. So here you have your free radical and free radical. That means that it's between the carbons. Okay, so that means your arrow should be like this, daripada tengah towards the carbon, daripada tengah towards the carbon. Alright. Okay, lepas tu dapatlah free radicals, your unpaired electrons. Okay. Yang ni pula, how? You're gonna get a free radical here at this carbon and hydrogen. So that means it's between carbon and hydrogen. Okay. Tak kisah awak letak dulu dekat atas ke, macam ni pun boleh. Asalkan awak punya arrow betul. Alright. So make sure itu awak break one single bond, you get free radical. That means that you have to use half-headed arrow. Okay. Ini. Okay. Alright. So next you have heterolytic cleavage. So heterolytic cleavage, it occurs in a polar bond. Polar. Ingat tak polar bond macam mana? Maksudnya awak punya atoms tu, they have different electronegativity. Contoh A and B kan? Macam ni, A and B ni. Okay, ada single bond. And then your A, let's say it is more electronegative. So A will have the partial negative charge and B will have the partial positive charge. That means that A is more electronegative. It will attract electrons. Okay, so a single bond breaks unsymmetrically in which both bonding pair electrons are transferred to the more electronegative atom, thus form a cation and anion. So that means that daripada that bond, both the electrons are transferred to the more electronegative atom. And this is denoted by a double-headed arrow. Okay. So maksudnya biasa punya curly arrow. Alright. Okay. So then you will form apa? You will form cation and anion. Faham kan kenapa? So here you have your bonding pair electron. So yang ni dia positive charge pasal apa? Sebab dia dah lebih proton daripada elektron. Ini pula negative charge pasal dia dah lebih elektron daripada proton. Okay? So that's heterolytic cleavage. Okay. The thing about heterolytic cleavage is that before forming your product, you can form two types of reaction intermediate. Okay. Tadi kalau homolytic cleavage, okay, awak akan form free radical as your reaction intermediate. Maksudnya before awak form product. Ni kalau heterolytic cleavage, awak boleh form carbocation dengan lagi satu is carb and ion. Alright. So this and this, they are reaction intermediates. They are intermediate macam transition state sebelum awak form out punya product, whether or not awak form out punya product. Okay. Alright. So since heterolytic cleavage dia occur between when you have polar bonds. Okay. So here you have C, CH3, CH3, CH3. So between carbons ni tak ada sangat beza electronegativity. But between carbon and chlorine, you have difference in electronegativity. So this chlorine is more electronegative. Okay. So it is more electronegative. Therefore, what will happen? How will the curly arrow look like? Your electrons will be transferred daripada single bond tu pergi siapa? The more electronegative one kan? So it will look like this. Gitu. Alright. Oops, sorry. So that is the curly arrow for forming carbocation. Okay. Now awak dah form carbocation. Okay. So sekarang dekat carbon awak ada positive charge. Alright. And then your chlorine, your anion has a negative charge. Okay. So carbocation is your reaction intermediate. Tahu? Okay. So both bonding pair electrons are transferred to chlorine atom. Okay. And a carbocation and anion is formed. Okay. Alright. So tadi saya cakap we can also form carbanion kan. So beza dia is that kalau tadi carbon awak is the more electropositive one and you have Cl the more electronegative one, so the electrons are transferred to Cl. Kalau ni sekarang ni elektron pula carbon awak is the more electronegative one banding dengan Li. Okay. Li has a partially positive charge. So that means that how will the curly arrow be? It will move to the more electronegative atom, which is carbon. Okay. So macam tu awak punya curly arrow. Alright. So maksudnya both the bonding pair electrons is accepted by this carbon. So that's why your carbon here now is a carbanion. It has a negative charge at this carbon. Alright. And lithium will be a lithium cation lah, lithium ion. Alright. Tu je. So this is basically the summary between the difference between homolytic and heterolytic cleavage. Okay. So now we're going to need to know whether awak punya reaction intermediate tu free radical carbocation dengan carbanion macam mana dia punya stability, are they stable or not? Okay, how do we know? We are going to look at the number of alkyl groups around your reaction intermediate atom tu lah. Okay, so basically the stability of your free radical increases as more alkyl groups or electron releasing group are attached to the carbon atom with the unpaired electron. So that means for free radicals, the more alkyl groups you have attached to your free radical, the more stable your free radical is. Okay, sebab aku ni ingat yang free radical awak ni dia nakkan elektron sebab dia kurang elektron. Okay, it is very reactive, so it wants electrons. Alright. So your alkyl group, the nature of alkyl group is that alkyl group tu macam mana? Hydrocarbon kan? It apa ni? Dia ada hydrogen dengan carbon lah. So basically dia tu electron releasing group. So that means that dia akan tolakkan electron density yang dia ada kepada awak punya carbon free radical. Okay. So lagi banyak awak punya alkyl group, lagi more apa ni? The alkyl group is an electron releasing group which will increase the electron density at carbon free radical inductively. So this will help stabilize the unpaired electron of your carbon atom yang ni. Okay. So this is the order of stability for carbon free radical. So if you look here in this compound, you don't have any alkyl group. Tak ada R. Okay, semua hydrogen. So it's just a methyl free radical. Yang ni pula, this is a primary free radical because you have one R group. This one is secondary because you have two R groups. And this one is tertiary because you have 3 R groups around your free radical, carbon free radical tu. Okay, so this one has the most number of alkyl groups attached to the free radical carbon. Therefore, the alkyl group, the electron releasing group, will increase the electron density at carbon inductively. Therefore, it will stabilize the unpaired electron of this carbon atom. So maksudnya lebih banyak alkyl group for free radical, lebih stable lah awak punya free radical tu. Okay. Okay. Same case with carbocation because carbocation is C+ kan. That means that awak punya carbon tu it lacks electrons, so it wants electrons. So what you're gonna do is, the same concept you're going to apply daripada free radical tadi. Okay, since alkyl group is an electron releasing group which will increase the electron density at carbon plus inductively, therefore it will help to stabilize the positive charge on the carbocation. Okay, sama je. Ini primary carbocation, ini secondary, ini tertiary. Okay, boleh Okay, opposite, lawan dengan carb and ion, the stability. Since carb and ion is a carbon with a negative charge, that means that your carbon already has so much electron density here. Okay, so it doesn't, if you give more electrons to this carbon, it will destabilize the carbon. So if there are more number of alkyl groups around that carbon, then the stability of your carb and ion will decrease. Okay, dia lawan. Okay, dia macam orang kaya yang dah banyak sangat duit, lepas tu awak pergi bagi BPN kat dia yang T20 tu, dia akan kacau stability dia. Make sense ke? Tak make sense kan? Baik awak bagi dekat orang yang memerlukan. Betul tak? B40, betul kan? Okay, so how do you stabilize carb and ion then? Instead of putting electron donating group yang bagi elektron, awak letak electron withdrawing group, EWG. Okay, so contohnya macam whatever substituent that is electron rich, like halogen. Okay, halogen banyak elektron, so halogen is very electronegative, so dia boleh stabilize your carb and ions by withdrawing the electron density towards itself. Withdrawing the electron density from carb and ion towards itself. Okay, kalau yang macam ni, ini R ni alkyl group, so dia terbalik lah dia punya case. Okay, this is a descending order of stability. Lagi banyak alkyl group, lebih unstable awak punya carb and ion. Alright, now we're going to look at reagents of organic reactions. Okay, so what are the reagents that we can have in your organic reactions? So there are two, your electrophile and you have your nucleophile. Okay, electrophile memang plus, nucleophile memang minus. So what are electrophiles? So awak pernah dengar tak hydrophilic ke pedophile ke? File tu maksudnya ada apa? Kalau lagu BTS hip hop file ke? File tu what does it mean? File means you like. Okay, so that means kalau pedophile maksudnya dia suka budak-budak. Electrophile means that dia suka electron. Okay, so electrophiles are ions or molecules that are electron deficient atau electron poor. So it doesn't have enough electrons, so therefore it wants electrons and it can accept electron pairs. Okay, so electrophile suka electron, accept electron. Okay, dia nak electron. Okay, the examples of electrophiles we have are cations such as these, carbocations yang tadi kita dah tengok, Lewis acids. Okay, they are electron acceptor. Okay, and then you have oxidizing agents such as Cl2, Br2, and etc. Okay, so your electrophiles, it doesn't have to be a single atom macam yang tadi tu je. It can also be an electrophilic site, maksudnya kawasan yang boleh act as electrophile lah. So this kawasan, this site is molecules with low electron density, so around a polar bond. So that means that contoh awak ada polar bond yang macam ni, carbonyl. Okay, Since you know that carbon is more electropositive than oxygen, so oxygen has higher electron density. This is a polar bond. So the low electron density site of this polar bond is where your nucleophile will attack. Okay, contoh nucleophile akan attack siapa? Dia akan attack carbon. Okay. Okay, contohnya haloalkene ni pula, since carbon is less electronegative than halogen, therefore this is partially positive. Sabar sekejap guys. Damn, what's that? Okay, sorry. So ni carbon, ni halogen. So that means that your electrophilic site is here lah. Nanti awak attack dekat carbon ni. Okay, sama juga untuk hydroxy compound ni, carbon dengan OH ni. Okay, so ini maksudnya awak kena tahulah macam mana nak determine where is the low electron density site of your polar bond. Okay, kena tahu macam mana. But you have to, senang awak ingat je lah, carbonyl, haloalkane, hydroxy compound. Okay, next is nucleophile. Nucleophile, a new negative. So nucleophiles are ions that are rich in electrons. They are electron rich, banyak electron. I have so much electron and I can donate this electron pairs. Itulah nucleophile. Nucleophile, apa nama dia nucleophile? Kat nukleus ada apa? Dalam nukleus ada proton. So that means that nucleophiles, they love positive charges. Okay, dia negatif, so dia suka positive charge. Alright, they want to donate. Examples of nucleophiles are anions, such as these, carb anion, yang dah baru belajar, Lewis bases. Okay, Lewis bases, they are electron donor. How does it look like? So contoh, if you have NH3 ni, NH3 ada lone pair. Okay, so that lone pair is makes it nucleophilic lah. Okay, boleh donate. So nucleophilic sites are electron rich sites. Contohnya carbon-carbon multiple bonds. If you have carbon-carbon double bond, carbon-carbon triple bond, atau benzene ring. Okay, so bila awak tengok multiple bonds ni, itu automatic awak fikir yang dia adalah electron rich, dia banyak elektron. Okay, so dia boleh donate. Okay, so maksudnya contoh awak ada electrophile, dia boleh attack electrophile tu macam tu. Okay, contoh awak ada electrophile, dia boleh attack electrophile tu macam tu. Okay, dia tangkap je terus, dia attack. Okay, macam tu tau. So nucleophile akan attack electrophile like that. Okay, so okay, now we know the reagents that we have. We have to have nucleophile, we have to have electrophile. So between this electrophile and nucleophile, there can be 4 types of reaction. So kalau dia minta type of reaction, awak akan ada these 4 je. You have addition, substitution, elimination, and rearrangement. Okay, so let's see the first one, addition reaction. How does addition reaction look like? Addition reaction is when you add your atom or group of atoms at adjacent atoms, maksudnya atoms yang sebelah-sebelah, with a multiple bond. Okay, so maksudnya in order to do addition reaction, selalunya you must have a multiple bond. Okay, tak kisahlah double bond ke triple bond ke. Okay, contohnya, what are the classes of molecules? You must have alkene, atau you must have carbonyl compounds macam ketone atau aldehyde. Okay, so itu akan jadi awak punya tempat untuk occur reaction lah. So depending on what you have, what nucleophile you have, what electrophile you have, you can have electrophilic addition or nucleophilic addition. Okay, so what is the difference between nucleophilic addition and electrophilic additions? So first, electrophilic addition, it is initiated, okay, it is triggered by an electrophile accepting electron from a nucleophile. So maksudnya siapa yang akan accept electron, maksudnya arrow akan pergi ke dia macam tu. Okay, it will look like that generally. So the typical reaction of unsaturated compounds such as alkenes or alkynes, okay, they will undergo electrophilic addition. So maksudnya kenapa dia cakap electrophilic addition, maksudnya awak akan add electrophile to your nucleophile. Okay, so in this case we have this alkene here. Okay, so it is your nucleophile, and then you have your bromine molecule ni. So this is your electrophile. So basically, okay, what will happen is that your nucleophile will donate electron to your electrophile lah. Okay, so how does it look like? So first awak ada carbon-carbon double bond ni kan. So saya tulis sini hydrogen. Ni ada hydrogen, lepas tu ni ada carbon and whatever. Okay, saya tak tunjukkan tu. Lepas tu awak ada bromine. Okay, how does it look like? So I'm not going to show you the mechanism yet, because nanti kita belajar dalam alkenes. Okay, so apa yang akan berlaku is that this double bond will disappear because kita akan buat 4 single bonds around your carbon. Dia akan pick up siapa? Dia akan pick up this bromine atoms lah. So nanti awak akan dapat yang ni, produk awak. So previously awak ada double bond, now you have single bond, and awak ada this bromine. Okay, so these 2 bromine are your electrophiles that are being added to your nucleophile. Okay, who is being added? So electrophile is being added, therefore it is an electrophilic addition. Next, you have nucleophilic addition. That means that you are adding nucleophile into your electrophile. So maksudnya it is initiated by a nucleophile which attacks an electrophilic site of a molecule. Selalunya it will occur for carbonyl compounds. So right here we know that awak punya carbonyl compound, it is a polar bond, so it acts as an electrophilic site because you have a partial negative site and a partial negative positive site. So that means that your nucleophile here, awak ada H plus dengan Cn minus. So basically your nucleophile Cn minus will attack your electrophilic site here. Okay, lepas tu macam ni. Okay, tapi macam ni nanti kita belajar lebih deeper lah. Okay, so nucleophile is the one that is being added into your electrophile. Okay, see here you have your nucleophile in your product. Okay, boleh kan? So double bond O tu jadi H, dapat H ni. Okay, so that is nucleophilic addition. Nucleophile is being added. Okay, next you have substitution. Substitute maksudnya awak gantilah, awak replace. So apa yang replace apa? We will see. We have 3 types of substitution. You have free radical, electrophilic and nucleophilic substitution. So a typical reaction of saturated compound is substitution reaction. Okay, so it will occur for alkanes. Okay, saturate maksudnya dia dah ada 4 single bond. Alkyl halides pun ada 4 single bond. Alcohol pun ada 4 single bond. And aromatic compound, ini ada 4 single bond ke? Tak. Tapi specialnya aromatic compound ni, dia akan preserve dia punya shape. So dia sangat stable. So it will not undergo addition, but it will only undergo substitution reaction. Okay, so free radical substitution maksudnya it will involve halogen atom that will form free radicals as the intermediate species. Okay, that means basically sebenarnya ni kan awak nampak UV kan. So ada alkane, halogen, UV, and then you have this product here. So that means that Cl tu actually dia akan undergo homolytic cleavage lah dulu. Okay, dia undergo homolytic cleavage and then dia akan form chlorine radicals. Okay, lepas tu barulah dia attack dekat awak punya alkane ni, awak punya electrophile. Okay, sorry. So basically because these are free radicals, so it is being substituted. It is substituting your one of the hydrogens. So that's why it's called free radical substitution. Okay, so sekarang ni Cl. Alright, faham tak? Cl is being substituted. This chlorine free radical is being substituted in your alkene. Next you have electrophilic this is substitution, betul kan guys? Okay, you're going to substitute in your electrophile. Okay, masukkan electrophile, dia akan substitute siapa? Okay, contoh here you have aromatic compound benzene. So benzene is very electron rich, so it acts as your nucleophile, and your electrophile is your bromine molecule. In the presence of FeBr3. Okay, macam mana boleh ada Br kat sini? Dia substitute siapa tu sebenarnya? So kat sini awak actually ada 1, 2, 3. Awak ada hydrogen kat sini. Okay, so basically you are actually substituting your hydrogen with your bromine electrophile. Okay, so that's why this reaction is called electrophilic substitution. Awak masukkan electrophile yang substitute H ni. Okay, then you have nucleophile. Nucleophile maksudnya awak akan substitute in your nucleophile into your electrophile here. So here you have, let's say, CH3, CH2, and you have bromine, and then you have OH minus your nucleophile, and then you have CH3, CH2, and you have OH. Nampak tak? So basically OH ni yang ganti tempat Br. Okay, okay, dia ganti tempat Br. So ini this nucleophilic substitution usually occur for saturated organic compounds. Contohnya haloalkane dengan alcohol. Okay, next you have elimination. Elimination maksudnya you will buang, you will remove. So you're going to remove daripada saturated molecule jadi unsaturated. Unsaturated maksudnya apa? Maksudnya awak akan ada multiple bond. Usually double bond lah. Okay, contoh, let's look at this reaction down here. So this is your saturated compound. Okay, okay, saturate syarat dengan atoms. Okay, ada 4 single bonds at each carbon. So when you undergo elimination reaction using ethanol and potassium hydroxide under reflux, reflux maksudnya awak at high temperature, you will be able to remove this HBr right here. Okay, so then when you remove this HBr, you will form an alkene. Okay, this double bond will form. So this is the HBr yang awak remove tadi. Okay, so awak akan form double bond between the carbons yang awak buang dia punya hydrogen and bromine tu. Okay, so this is an elimination reaction. Kadang awak boleh eliminate water, awak boleh eliminate other macam HCl ke whatever lah, HX. Okay, H2O boleh remove. Okay, and then you will form unsaturated molecule. Okay, ini unsaturated molecule ni, alkene. Okay, finally you have rearrangement reaction. So rearrangement maksudnya awak akan ni lah, susun balik lah basically. Apa yang awak akan susun balik? It is a reaction that results in a product with a different carbon skeleton from its reactant. So basically awak punya carbon chain tu berubah lah. Okay. So this will result in the formation of unsaturated molecules. Okay. Alright, so here, down here, your example is a tautomerism reaction. Okay, on your left here is actually a compound called enol. Why is it called enol? It shows that it has an OH. Okay, and here you have a keto. Alright, so it's basically macam it's a ketone lah. Okay, so in this reaction, what happens here is that you rearrange your hydrogen punya position. Betul tak? Awak rearrange awak punya hydrogen punya position. Daripada dia ada kat sini, sekarang awak punya double bond ada kat sini, and you have hydrogen here. Okay, and then you form this keto. So how does it, macam mana dia punya alkylic arrow boleh agak tak? Boleh agak tak? Let's say kalau saya expand ni Okay, how does it look like? It actually looks like this. Okay lah, daripada keto ni dari sini kan, this one masuk sini, and then this one will be captured by this one, negative charge akan capture hydrogen. So ini akan masuk sini. Sorry, saya tersalah. It basically looks like this. This one will capture hydrogen. This will go here, and this will go here, masuk balik. Okay, so that's how you get this one. So daripada sini pula macam mana? So basically dah form double bond kan? Macam nak form double bond kat sini? This one will go here. This one will capture the hydrogen here. Okay, ini saya just main ingat daripada zaman degree, tapi I think it's about right. Okay, this arrow is the sign for tautomerism. That means that dia bukan reversible arrow yang normal yang kita at equilibrium. Ni maksudnya your equilibrium shift to the right. So maksudnya this keto punya compound, it is a much more stable compound lah. Dia akan lebih low energy, and it will exist easier daripada awak punya enol ni. Your enol is very reactive, therefore dia akan react untuk form keto. Okay. Alright, so now we have to identify the type of chemical reactions below. So how are you going to answer this? First, you're going to look at your reagent. Okay, it undergoes acid reflux. Okay, react dengan concentrated sulfuric acid under heat, and it will form an alkene and water. Okay, so maksudnya awak tengok dari sini, awak ada saturated molecule. Lepas tu sekarang awak ada alkene. Okay, lepas tu awak ada water. That means awak ada, since awak eliminate water, maksudnya this is an elimination reaction. Okay, this is an elimination reaction. So basically you are removing this hydroxide ion and this hydrogen. Okay, dia nampak macam ni sebenarnya. Okay, awak ada hydrogen, awak ada OH. So awak remove yang ni. Lepas tu awak akan dapat carbon-carbon double bond. Okay. Okay, next you have this haloalkane react with NaOH, and then you will form alcohol and sodium bromide. So apa yang kita nak tengok? So tengok awak punya reagent yang ni, Daripada ada Br, sekarang ada OH. Okay. Apa maksudnya tu? Okay. Apa maksudnya tu? Okay. Maksudnya it is a substitution reaction. Okay. Substitution reaction. But what type of substitution reaction? Is it electrophilic or nucleophilic? That means you have to see OH ni dari sini dia act as apa? Dia act as apa? Kalau OH minus tu, dia act as nucleophile. So that means that this is a nucleophilic substitution reaction. Sebab nucleophile yang kena add dekat dalam awak punya electrophilic sites. Okay. So this is nucleophilic substitution. Saya cakap add ke tadi? Okay, jangan guna perkataan tu It is substituted. Okay. Okay, next we have this benzene. Alright, so this benzene here. Kalau benzene je awak kena ingat yang dia adalah electron rich. That means that dia mesti akan jadi awak punya nucleophile. Okay, so if you look here, you have H, then now you have Br. Ni saya tersalah. This is actually supposed to be CH3 awak. Betul kan? So, daripada H, awak dapat CH3 as your substituent. Lepas tu here you have HCl. Mana datangnya? Datang daripada ni lah, H dari sini dan then Cl yang ni. Okay, betul? So, that means this acts as your apa ni? Electrophile lah. Okay, CH3 tu awak punya electrophile lah. Okay, so what type of reaction is this? Benzene takkan undergo addition reaction. You need a lot of energy and a lot of heat in order to do that. So it is a substitution reaction. Okay, what type? Apa yang kena add? Apa yang kena substitute? CH3 kan? Awak punya electrophilic substitution reaction. But since this is a benzene ring, awak kena tambah satu lagi benda kat tengah ni, aromatic. So maksudnya it is an electrophilic aromatic substitution reaction. Okay. Right, number 4. So tengok awak ada CH3 CH2OH, HCl, and then awak dapat CH3 CH2Cl and water. So what type of reaction is this? Is this an addition? Kalau addition mesti ada alkene, ada multiple bond. So sekarang ni tak ada kan? So that means that this is a substitution reaction. Okay, so now kita determine HCl ni, the Cl minus that is added into your, substituted into your alcohol, is it an electrophile or apa ni? Nucleophile. Okay. So apa tu? Kalau awak tengok sini nak tahu, nak tengok adakah ini electrophilic site atau nucleophilic site, siapa yang attack siapa, awak besarkan awak punya, expand awak punya apa benda, awak punya structure ni. Okay. Okay. So ini akan jadi partial negative, this will be partial positive. Darn guys. Sabar jap. Sambung saja. Alright. So this is a partial positive side and this is a partial negative side. So that means that this is your electrophilic site. So what you're going to do is you are going to use this nucleophile to attack your electrophile kat sini. Okay. So what type of substitution reaction is this? This is an nucleophilic substitution reaction. Okay. Tahu kan kenapa dia substitution? Sebab dia bukan addition. Kalau addition daripada multiple bond. Okay. Number 5. Asal awak nampak UV ni je, Cl2, it means that it is a free radical. Okay, so free radical apa? substitution ke, addition ke, elimination ke, apa lagi, apa-apalah, whatever. So here you have CH3 CH3. So maksudnya awak ada hydrogen kan, betul tak? Okay, pasal awak ada Cl yang awak akan form free radical dulu as a reaction intermediate. So here you have CH3 and then CH2 dengan Cl. Betul? So maksudnya apa yang awak buat ni, awak add ke awak substitute? Awak substitute, okay? Awak substitute this hydrogen with this Cl. So that means that this is a substitution reaction. Betul? So what substitution reaction is this? Awak masukkan free radical kan? So it is a free radical substitution reaction. Okay, yang ni boleh tak awak buat sendiri? So yang ni saya bagi tahu yang this is nucleophilic addition. Aduhai, patutnya saya tunjukkan juga. Tak payah tunjuk yang tadi tu. Ini electrophilic addition reaction. Kenapa? Macam mana awak nak tahu dia addition? Sebab dia daripada unsaturated compound. Maksudnya awak ada multiple bond jadi saturated compound. Okay? And awak tak ada eliminate apa-apa, so that means that dia bukan elimination. Okay? Alright, so I think that's all for today, guys. So ini akan jadi awak punya chapter for assignment. So I hope that you, tak apalah, kita boleh je study lepas ni. Awak boleh je tanya soalan lagi. Okay? Alright, so I think that's all for today. So buat tutorial questions number 11 to 14. Alright? Okay, bye. Thank you.